So, last week I talked about minimum spanning tree, where we are looking at minimizing the distance, minimizing the cost and everything. So this week we are going to look at maximum flow. How are we going to get the maximum out of a network? All right? So this bit here, again, is very systematic, and the approach is step by step. You've got to be really following what I do, and you cannot skip step. If you skip step, the whole thing will just go haywire. It will not work. All right? So let's start off. What I would really like all of you to know is what is a flow network. It is actually a directed graph where each edge has a capacity and the flow associated with the edge. All right? So you must understand that a flow network has a source and a sink. So where things come in and where things go out. All right? It's important for you to know the source and the sink. And what else do I need to tell you? You need to be able to determine the maximum flow allowed in the flow network using a systematic approach. I am really going to stress the word systematic. And from what I can gather, a lot of the time this question will be in the Calc 3 because you don't really need your calculator. So in fact, I would say a lot of this network question will be in Calc 3. Calculator is not as important. All right, now, let's have a look at this network. You haven't got it in front of you, but I want you to observe. So a flow network is actually a directed graph with the label nodes. The nodes A, B, C, D, and E or whatever, it could be 1, 2, 3, 4, 5, 6 or whatever. So it has to be labeled. It must have a capacity, which means if water can flow in here, despite the maximum amount of water that can flow through is 100 liters per second, for example. Despite the maximum amount the water could flow through is 120 liters per second. That's for example. Or you can think about it, let's say you are mining a conveyor belt. You're going from one conveyor belt to the factory. So this conveyor belt can maybe take 100 tons per hour, and that could take 120 tons per hour, that sort of stuff. All right? So that's capacity. Now, a source. All right? Can you please write this down? A source is a vertex with no incoming edges. All right? If you look at C, that is incoming and that is outgoing. All right? You've got arrow in two directions. So the source is everything is going up from the source. You are moving away from the source. Everything from the source is just an up arrow. All right? And the sink, everything goes in. So a sink is a vertex with no outgoing edges. So you must be able to define a source and a sink. In fact, most of the time, what the question will be, what is the source, what is the sink? Not even asking you, but identifying the source and identifying the sink. All right? So source, everything comes from there, everything goes out. Sink, think about the kitchen sink, everything will be drained out. All right? All right? Happy? Yeah. Now, so in this case, we know that A would be the source, and Z would be the sink. Okay, this network, I show it to you this way. But sometimes the network that you get in the exams, it will be funny ways. So you've got to really know how to identify the source and the sink. It might be the source might be up from there, and then the sink might go up from here. So it might travel around the network, comes out from here, or from here to here, that sort of stuff. So beware when you are identifying the source and the sink. All right, next. Flow network can be used to model the flow of fluids. For example, water, oil, gas, sewage in a pipe, traffic in a road or rail system, current in electrical grids. There anything similar that travels through a network of nodes. All right. In a maximum flow problem, the goal is to send as much flow as possible between the source and the sink. That's important for you to know. The amount of the flow will be subject to the H capacity of the constraint. So, if you think about this only, if we ignore B and D, all right, let's go from A to Z. What happened? There's 100, there's 120. So really, the limit is 100, correct? You cannot use the 120 to capacity. The capacity for this, if you just look at A, C, and Z, is only 100. Right? So this, you must do this very systematically when you look at question like this. So let's think about what I did here. So source A can supply water of 350 liters per minute. So here from there, could be from let's say a reservoir, a well, or something like that. You can supply 350 liters of water per minute. So what happened is, can all these 350 liters per minute be delivered to the sink, Z? Now, let's have a look. Like I say, if I look at this first, A, C, and Z, ignoring B and D. Just ignoring B and D. Alright? So let's not look at that. What is the maximum we can get? Flow through that. 100, correct? Because you cannot go through, you cannot have more than 100. That's the maximum capacity. Although this is 120. Yeah? Agree? So that's A, C, and Z is 100. Let's have a look at the next thing. A, B, and Z. What is the constraint? Where's the limiting factor? B to Z is limiting factor is 50. Although 100 can come out from this side, but this is limiting what can go through. So therefore, A, B, Z is 50. And finally, if I look at, forget about that, everything else, just A, B, and Z. 150 and 200. Where's the limiting factor? 150, correct? So therefore, what you would say is, I follow one path to find the maximum. I follow the second path to find the maximum. I follow the third path to find the maximum. Alright? Path 1, A, C, and Z. Path number 2, A, B, and Z. Path number 3 is A, D, and Z. So this is a pretty straightforward question, but you will not be asked something like this. It will be a lot more complicated. So from here, you can see that the maximum flow which can be delivered to sink Z is 300 liters per minute. What you would be asked is, if situation like this, you'll be asked to identify the excess capacity and what you could do to the network to actually bring it up to 350 liters per minute. That's normally the question. So I will go through some questions tomorrow. Alright, so the algorithm for determining the maximum flow. I didn't print this for you because it's really not worth it. You just have to follow me step by step in a few minutes, alright? Identify the source and the sink, that's definite. Estimate the range of maximum flow. Occasionally I skip that step. I definitely identify the source and the sink. And then define the specific path or route from the source to the sink that has flow capacity available. Work from the top to the bottom of the diagram. My recommendation, always from the top to the bottom of the diagram. Then determine the maximum flow along this route. Subtract the maximum flow from all arcs on this road and replace with available capacity. Repeat 2 to 4 until you completely exhaust the whole network. Alright? Now, let's have a look at example 1. You are given example 1. Alright?
Would you mind going back?
Yeah, no problems at all. If you want, I'll print it out for you and I'll photocopy for you tomorrow. Alright, I'll do that tomorrow. Alright, so remind me if I don't do that, I'll give it to you on Wednesday. Now, so example 1, I want you to think about the maximum flow. How are you going to achieve the maximum flow for this network. Look at this network here. You've got this bit coming through here. Now F, for example, you've got those which go through to F. And two sources coming in. This one source, two going in and two going out, and so on and so forth. Alright? Now, it's very confusing if you don't do it systematically. When I say in my summary, work from the top to the bottom of the diagram. I mean, you always take this route first, and then you can take this route, and then you can take this route, and then here, and then this will be the final one. Alright? Step by step. Now, use different color pen and follow me, please. So, example 1, what I'm going to do is, I am going to look at the highest, the topmost. The topmost will be A, C, F, G, and H, correct? So, highlight everything, A, C, G, F, and H. You can highlight it first, and then later you remember crossing it up. Highlight first, and then cross out the maximum flow a bit later. Let's highlight this one. Or if you don't want to highlight, at the bottom of the page, write down A, C, F, H. Alright? No, F, G, H. I forgot the G. A, C, F, G, H. Now, looking at all this, which one is the limiting factor? 280 is the limiting factor. So although 400 can come out from, oh, let's go back one step. My fault. I forgot to identify the sink and the source. To identify the sink, you can see that A would be the sink because there's only everything coming up, nothing going in. C, F, B, E, and D, and G cannot be the source of the sink because you've got something going in and something coming out. H, everything goes in. So H is the sink. You must always identify that. Alright, unless it's specifically told to you by the question. So highlight that, and then looking at that. So if maximum is 280, if 280 flows through here, through here, through here, and through here, that will have no more capacity, correct? Will there be capacity from here? Spare capacity from here? Spare capacity from here? And spare capacity from there, correct? Yeah? So how do we work it out? What you do is cross that one out and make sure that it is 0. Alright? Just follow me. Make sure that that's 0. You know that therefore there's no more flow available from CF. That is the maximum you can go. Alright? And then everything along this path, you take away 280. Everything along this path, you take away 280. So therefore, you have ACFGH. The maximum capacity would be 280. All right? This is step 1. Therefore, you need to do it step by step. If you don't do it step by step, you get confused. Now, step 2. You can see that this one coming out here, there's no other pipes going anywhere else. So, even with the spare capacity here, there's no pipe between C and E. So therefore, you can't use this one anymore. Right? So you've got to think about the next bit, which is A, B, E. Look at this. F here. There's a spare capacity. So from here, you can actually go up, come back down, and there's another spare capacity. Alright? So, the next one, I've written that down, root A, C, F, G, H, carry 280. And the next one, highlight that. Or if you don't want to highlight, just write it down at the bottom. So here, if you look at whatever is in there, AB is 300, B is 150, EF is 200, FG is 170, GH is 320. What is the limiting, which pipe is the limiting factor? Which one? BE. So that would be 0. Once at 0, everything along this road, you take away 150 from everything there. Alright? So if you take away everything from there, you have to write it in the diagram so that you know you still have spare capacity. GH, yes, you have to. Sorry, I forgot to type it again. Alright? So now you know BE is, well, in the word dead, you can't use it anymore. Right? Those two, you can't use that anymore. Alright? So here, you can come the next bit. Therefore, you need to write down A, B, E, F, G, H carries 150. Alright? Now, here, next bit, you can think about going from A to B because there's still capacity. Right? And then, although this is 0, but you can still go through here. Right? And then up here. Now, can I go up here? Yes, because that's 50 is still here. 20 is still there. You still can go that way. Alright, up F, G, H. So I can draw that. See, every time I do a new road, everything with 0 is not there anymore. Right, so the next one is A, B, D, E, F, G, H. And that is the maximum capacity, 20. So get rid of that. That's 0. And then change everything else. So you can see that it gets a bit confusing sometimes if you don't follow it step by step. Alright? So you must follow step by step. Make sure that you exhaust every single pipe or every single route. And then, if you look at this is 0. I cannot use this one anymore because if I go up there, there's no flow coming out because that's already maximum. Alright, so therefore, I will change it to this. So I've got A, B, D, E, G, H. Now looking at that, this is 130, 180, 130, 200, and 150. So therefore, we know that 130 is the maximum flow for this road. So cross those two out straight away. 0, 0, and then work out the others. All right? You have to do practice. If you don't practice that, you will get confused. So after that's done, that's only one bit left, which is A, D, and H, correct? Agree? All agree? So A, D, and H, that is 100, 100, and 150. And of course, the maximum flow will be 100. And there's 50 left. Now, look at the road now. We're looking at A, D, and H. So, summary. What I've done is, doing all this, I can just write down, all right, I type all this out. In the exam itself, you can just write down A, C, F, G, H, 280, A, B, E, F, G, H, 150, A, B, D, E, F, G, H, 20, ABDEGH 130 and ADH is 100. So the maximum you can go through the network is 680. Alright, so the maximum flow from source A to sink H is 680 units. Yeah? I mean, it is a lot of practice, a lot of going through. Now, you can, it doesn't matter whether the circle is 0 or that's 0. It really doesn't matter because they are on the same road when it is 0. Alright? So what happened is, all this, whatever is left, you've got the spare capacity. Alright? Which means I'm going to go to the next bit. This is the graph, shows the flow along each pipe. It is possible to determine the unused capacity. So for example, the flow along here is just 400 minus 120, which is the maximum flow here. Alright? So you could work that out. You could work that out as 400 minus 120. Alright? So here, 300 minus 0 is 300. 100 minus 0 is 100. Here, 200 minus 50, that's 150. Right? 200 minus 50, 150, that's 0. 150 minus, that's 150 maximum. That's 100 because it's 150 minus 50, and so on and so forth. Alright? Anything with 0, the original capacity goes into the bottom. Anything which is got 0, original capacity, take away, what is the maximum flow? Yes? Some of you are looking a bit puzzled. Ask me any question. It all makes sense? It's a lot of practice. It goes step by step. You've got to think about the capacity. How big the capacity is and how small the downstream pipe is. Or how big the upstream pipe is and how small the upstream pipe is and how big the downstream pipe is. Alright? So if it makes sense, what you need to really notice, once you have actually drawn the maximum flow, alright, indicate all the maximum flow. So here, I'm going to circle that and show that. This is 150, 150 minus 50. Alright? Now, notice that at maximum flow, the sum of flow into a vertex is the same as the sum of the flow out of that particular vertex. So if you look at B, whatever comes in is 300 and going up 150. Those two adds up to be 300. Correct? Here in E, 150 and 150 going into E. Going out is 170 plus 130, which is 300. Going into G, those two adds up to be 580, and then going out from G is 580. So at maximum flow, whatever goes in, goes out. Alright? Any question before I move on? And you can see that whatever came out from the source, 680 is the same as whatever goes into the sink, which is 680. Yeah? Alright, I'll move on. You have to do some practice, this one. Example 2. Now, this is what I've given to you. Determine the maximum flow. This time I've given you the unit. Liters per second, possible for the network of pipe shown below, with point A and the source and point F as a sink. So here, I specifically said, I specifically told you what the source is and what the sink is. Not asking you to identify. And then we draw the network showing the flow you would direct each pipe in order to achieve the maximum flow at F. So here, for example, this one, this is using the same network, but all these are the maximum flow. All right? So that's what you have to redraw if you do that. And if the maximum flow were to be increased by 10 liters per second, which pipe would you upgrade and what would the new capacity of the pipe be? All right, now, let's have a look. I'm going to start off by guiding you. If oops, hang on. What I'm going to do is, I'm going to start off systematically. I will go A, B, E, F. All right, the uppermost pipe, the most from the top to the bottom. A, B, E, F. I have got 30, 20, and 40. So I know that is a maximum, and that will be 0. Correct? So therefore, 30 minus 20, I've got 10. 40 minus 20, I've got 20. And I write down there, this is 20. Maximum flow between A, B, E, and F. All right? Now, next. Since I cannot use BE anymore, I can use A, B, C, E, and F. Correct? So A, B, C, E, and F, which is this bit here. A, B, C, E, and F. That is already gone. I can't use it anymore. So from there, I noticed that 10 would be the smallest. Correct? So that will be 0. And that will be 20. That will be 10. And that will be 10. Step by step, I've gone through the uppermost and then the second one. Yeah? Alright? So now I know that there is 0, I can't use AB anymore. I'm forced to use AC now, correct?
Yeah.
So now AC, alright, AC, I'm also cannot use BC anymore because AC has to go that way, it doesn't go back to CB. So I'm going to go A, C, there's a capacity here 10, E, and F. Alright, so the next one will be, oh hang on, let me write that down first. The next one is 10. Alright, it's AB. So I've got A, C, E, and F. From the source of the scene, A, C, E, and F. So the maximum, this is 10 and 10. So that will be 0, 0, I'll write down 10. And AC, that is 15. Alright? Now, going from A to C, I still have capacity of 15. Alright? When I go to C, I can't go up there anymore, I'm stuck. That's 0. So I've got to go through A, C, and F. So A, C, F, 15 and 10. What is the maximum flow? That's 10. And that will be 5. Alright? So I've worked through all this, and I know I can still use AC because I can go AC, D, and F because I still have capacity left. Correct? So the next one is A, C, D, and F. That will be 5 because that will be 0. That will be 5, and that will be 40 minus 5 is 35. Alright? So now I've exhausted this bit. I can't go anymore. Therefore, I'm forced to use AD. AD is 35, AD and F. I can't go back, so I'm going to do AD and F. AD and F, which is 35. Take away 35, 0, that will be 10. See how I've done it? I've done it step by step, and I've exhausted every single thing. So therefore, the total maximum flow is the sum of this. 20, 30, 40, 50, 50 plus 30, that is 80 liters per second. Go back to read your question. Your question said the flow is liters per second. So you need to make sure that it's liters per second. All right? Now, the next bit, you are actually asked to draw the maximum flow. So, what I need to do is show this very carefully. To draw it, AB, make sure that you know you are sketching it correctly. I've given you something and it makes it a little bit easier. So that is A, B, E, C, and D. All right, let's go back and have a look at the capacity. So AB capacity is 0, so therefore directly translate it down to 30 here. And then go back, BC and EF, everything just directly translate it down, 20 and 40. That's the maximum flow per pipe. Now, the maximum flow for BC is 20. It's 30 minus 20, which is 10. All right? And then between CE, 20 minus 0, that's 20. Back. AC is 25. CF is 10 minus 0, that's 10. 25 and 10. And go back. CD will be 10 minus 5, which is 5. Go back. 25 minus 0 is 25. 40 minus 10 is 30. 25. So this is how you actually draw the maximum flow. All right? Now, the question, part C, is a typical question. If the maximum flow were to increase by 10 liters per second, which pipe would you upgrade and what would the new capacity of the pipe be? So, if the maximum flow now is 90. Look at the whole network there. Here, if I upgrade this to 20, which means, because I don't have the 0 capacity here, if I upgrade this to 20, I can still have a flow here. But I don't have any flow coming out from AB, so you can't do that. Alright? Look at something like this. If I want to increase by 10. So if I increase this to 15, that's extra 10, because it's a 10 liters capacity, so I can increase that by 15. However, AC doesn't work anymore because there's 0 here. Alright? You are only allowed to upgrade 1 pipe, not 2 pipes. So therefore, if I look at A, D, and F, that is pretty much the solution, because I can upgrade AD to 35, and then that would be, there's a spare capacity of 10. Look at the downstream spare capacity. Alright, so if I increase that by 10 to 35, and I would have enough capacity for me to push that up by another 10 liters per second. Alright, so this is looking at the network. Generally, question like this, you have to look at where the spare capacity is. And then, yep.
The spare capacity at CD is still should do.
CD is still 5, yep. However, AC, there's no more spare capacity coming up.
But you said there's no more at AD either.
Yeah, AD there's no more, but that's the part that I can increase to 35.
Why don't you increase
Upgrade.
the CD then?
Yes. What I want is the downstream here, there's a spare capacity of 10, correct? So if I increase this by 10, increase this by 5 actually, to make it 20, I should be able to bring another 10 flow to there, correct? However, upstream, this is already at maximum, so you can't do that. You can only upgrade 1 pipe. Whereas here, you can upgrade, if you upgrade AC, you cannot get 10. You upgrade AC to 30, that maximum is only 5 there. So you can't do that. Whereas if you upgrade AD, you've got a spare capacity of 10. That would be 35. So therefore that's 10, and you can use this capacity. All right. So this is the logical thinking that you have to have in terms of looking at what's the downstream and what's the upstream. So therefore, to answer the question, upgrade AD, upgrade AD to 35 liters per second. All right. Sometimes some question will ask you, if I upgrade this pipe by a certain capacity, what will be the maximum flow? All right. So I will do some question tomorrow. So I'm going to stop. Caution. Here, if you do not do it step by step, you will have a lot of problems. So say for example, if I jump straight to A, B, C, D. If I go straight to A, B, C, D, you know that the maximum will be 40, correct? Yeah? However, it is not true, because by inspection, you know that you could use BD. Right? So this is not correct. So if you start doing it step by step, you will go for A, B, D, which means I have got 40 and there's 10 left. All right? I know I can't use AB anymore, and I can use AC, ACD. ACD is another 40. 0, 0. So therefore the maximum flow is 80 and not 40 if you don't do it systematically. This is a simple network that I want to show you to make sure that you understand you must always start from the uppermost. You cannot use the middle straight away. If you use the middle straight away, that will be the issue. You will not use BD at all. So this one, I'm going to put a big cross. Do not do that. Do it step by step. All right? So I've got a few questions for you to do in club. Hopefully you've understand what a flow network is. Understand the flow network has a source and a sink, and you'll be able to determine the maximum flow allowed in the flow network using what I call a systematic approach.